presenting #1 supplier of optical transceivers, Terahop, also known as InnoLight. Please go ahead, Ranjan.
Thank you, Vlad. I really appreciate the opportunity to discuss with community. Certainly Open CPX MSA. The mission here is really keep the CPO, MPO open. This is really necessary for the next phase of AI scaling growth. So happy to share our views how the Open CPX MSA can help in that direction. Yeah, so here just reiterate main missions of CPX MSA. Certainly one of the key driver here is to enable a healthy open CPO, MPO ecosystem, so allow multi-source to support this very high volume, rapid growth industry. And this has really also helped greatly enhance the supply resiliency in this environment. It's actually very critical, like Justin described earlier, deployment is actually one of the very key factor to make sure a new technology can be successfully deployed. And the early founding members, also early contributors now, include a very large spectrum of the optical industry. And this represents a very large share already of the existing optical supply chain. Consists of optical suppliers, IC suppliers, connector suppliers. Now we also have system integrator in the mix to contribute to define the Open CPX MSA. And certainly connectorized design we promote here allow us to support mix of copper and optics. This is really critical in terms of evolution of system architectures, particularly for scale up. And also the easy service and repairing is also a critical factor. That's actually really reduced overall TCO of the system deployments. And also like to emphasize the integrated laser and external laser options, because this is really allow the continuation and evolution of all the available existing technology capabilities can be ported over from the front panel optics to the MPO, CPO deployment. Integrating laser with actually large body of deployment in the field with a very high reliability and low fit. This is greatly simplify the system design, allow many use cases can be available to this kind of new technology deployment. And being an open CPX allowed to incorporate multiple technology options. So we started maybe with silicon photonics emphasis, but certainly we are anticipating a pipeline of other technology can come in the pipeline, including VCSELs and micro VCSEL arrays, and Tiflin certainly coming in the pipeline as well. And I think previous speaker also included this richness of deployment scenario, including MPO, CPOs. These actually greatly expand the use case of these optical engine with an open ecosystem. So here we are basically illustrating where the open CPX type of optical engine with an open ecosystem can be deployed in multiple scenarios. If you're looking at from the left side, this illustrating an example, if you have an ASIC or accelerator and needs one or two MPO, this is actually can be reasonably easily implemented with optical engine sitting on the PCB very close to the ASIC. And then the next really showing you can also use a similar approach, but letting the engine sitting on the PCB very close to the ASIC or switch ASIC. So one or two basically allow you to look at both on the scale up between the server node and also the switch node. If you're moving on, you can actually see the availability of CPO type of deployment if the ASIC substrate is opening up for a socketed footprint. So that basically illustrating an example, same optical engine supported by OpenCPX can be deployed in a CPO scenario. And the right chart showing a little bit different configuration, but this is in industry brewing and coming up. in the high throughput, high capacity switches, you start to see this, I call it IOA, integrated optical attachment. It's a derivation of integrated copper attachment. So this is an illustration where if you like to see both copper and optical deployment, you can actually use this approach of attachment directly to the substrate or interposer with a very high density, like elastomer type of connector, allow you to reduce the loss between the ASIC and the optical engine. And you can still deploy either copper with a CPX connector or optics like Open CPX supports. And by the way, earlier we talked about the type 1, type 2. So this is another area where you can actually pick and choose different type of connector systems within the MSA, either type 1 or type 2, that give you a flexible system integration options. Next, please. So here is a chart showing our contribution, availability of very high reliability and mature silicon photonics to support Open CPX MSA type of deployment. This is actually showing you our track record of deploy very high volume and accumulated close to 100 billion device hours with a very low fit rate. That means these capability or engines already can be utilized to support Open CPX MSA without resorting to exotic technology where the ramping and into a very high reliability concern can be adequately addressed by these kind of mature silicon photonics. Next, please. Again, this is our example at OFC in March. We basically already did a demo. This is called a pre-spec, but already using the Open CPX MSA defined RF connectors, showing a decent performance in this scenario, actually going over reasonably high loss from ASIC through the PCB and to the MPO configuration. We're showing link performance can be demonstrated in the 10 to minus 9, 10 to minus 10 BR levels. Again, this is a very early demonstration. Certainly, I think in the next few months, we're going to see significant more activities in the Open CPX MSA, building up opportunities to demonstrate the capability of this kind of optical engine performance. Next, please. So Justin and several other, Matt, also showing the potential Open CPX roadmaps. So here I just use the opportunity to showcase. We started with phase 1, which is 6.4T for DR8 as an initial project focus. And we do have opportunity to looking at an upgrade. If you're looking at the electrical lanes speed side, there is certainly anticipation the 400 gig per lane is coming up. So we are looking at both in the connector upgrade, Matt actually illustrated there's potential there, and the optical engine upgrade. That way we actually have an opportunity to then upgrade to 12.8T for DR8 type of engine capabilities. If you go into the right, there's hyperscaler and several accelerator companies sponsor so-called OCI MSA. This is actually a new PND, basically practically define what the media side of the MSA coming up. And this actually can be implemented, embodied by the Open CPX MSA as well. So this is more of a complementary capability we're looking forward to in the next phase of deployment as a potential to implement OCI type of optical PMD, but supported by the physical support of the Open CPX as a potential roadmap items for us to discuss and move forward with. That concludes my discussion. Thank you.
Thank you, Rank Chair.